Okay, question 4. It says filtration is a method used to separate insoluble solids from liquids. Okay, so I'm just going to highlight those words. So it says figure 9 shows the apparatus used for filtration. So let's have a look at the apparatus. So I've got, they've labelled A, B, C, D, and they've labelled the filter paper. So which letter shows the filtrate? Okay, so I just have to know this, that the filtrate is the liquid that passes through the filter paper into my conical flask, and so the answer is D. Then it says the filter paper has been labelled. Explain. Okay, so explain. I know this is an explain question, so I need to have my point and my explanation. Explain how the filter paper separates the insoluble solid from the liquid. Okay, so how does it separate it? Well, I know that the liquid goes through the filter paper, but that the solid remains on the paper. So that is how the two are separated. Okay, part B. Some food colourings are a mixture of soluble coloured substances. Mixtures of soluble substances can be separated by paper chromatography. I'm going to highlight soluble as well, just to remind myself that these are soluble coloured substances and I'm separating them by paper chromatography. Paper chromatography was used to try and separate the coloured substances in 5 food colourings, V, W, X, Y and Z. Figure 10 shows the spots for the 5 food colourings on the chromatography paper at the start of the experiment. The paper was placed in a beaker with the bottom of the paper in the solvent. Identify the stationary phase in this experiment. So the stationary phase is the paper. Give a reason why the spots of the food colourings must be above the level of the solvent when the paper is placed in the solvent. So here's my solvent, there's my solvent. And why do the dots at the starting point have to be above this solvent line? Well, if they were in the solvent, they would mix into the solvent. So that wouldn't work because then our dots wouldn't separate up the paper. So my reason is that it's to stop the spots mixing in with the solvent, because I don't want that to happen. Okay. Right, let's do figure 11 shows the chromatogram at the end of the experiment. So the experiment's happened now. There's V, W, X, Y and Z. There's my start line and here's my solvent front. So the solvent has gone all the way up the paper and they've removed the paper from the experiment at that point there. So give the reason why the spot of food colouring V has not moved during the chromatography experiment. Now, they've told me that at the beginning, actually. If I look back at the little bit that I've highlighted here on part B, some food colourings are a mixture of soluble coloured substances. And so the whole way that chromatography works is that the dots of colour that we're using dissolve in the solvent and pass up the paper as the solvent moves. So V, therefore, didn't dissolve in the solvent, which means that it is not soluble. So part 4, explain. Okay, so I need a PE question here, so point and an explanation. Explain by referring to figure 11. So I have to include that in my answer. Which food colouring contained the greatest number of soluble coloured substances? Okay, so I need my point and my explanation. So which one had the greatest number? If I look here, so V was not soluble, W's got 1, I'm going to put that there. X has got 2, Y's got 1, 2, 3, and Z's got 1, 2, 3, 4. Okay, so Z had the most, and now I'm going to explain. Okay, so that it was Z because it had the most dots on the paper. Okay, part 5. One coloured substance in food colouring X moved 5.8 centimetres when the solvent front moved 6.6 centimetres. So X moved 5.5 and the solvent front moved 6.6. Calculate the RF value for this substance, giving your answer to 2 significant figures. And I'm going to highlight that just to remind myself. So when I work out the RF value, what I'm going to write down, or I'm going to calculate, is the distance that my value moved. Okay, so the dot, so it moved 5.8 divided by how far the solvent went, 6.6. So it's easy as that. It's just the distance that your substance went divided by the distance that the solvent went. So I can pop that into a calculator and it comes out as 0.878787, and so it goes on. And so I need to write my answer as 2 significant figures. Okay, so I'm going to take my first 2 figures here, which would be 0.87, but because my third figure is greater than 5, I'm going to change my 7 to an 8. So my answer will be 0.88. And I know that I'm right because RF values are always less than 1 and greater than 0.